At the end of the module, I left you a practice problem that hopefully you worked through, but whether you did or not, I want to show you how quick and easy it can be to solve a practice problem like this if you use Excel. So if you recall the situation, the research question was, is there a difference in the grades that students get at 86 versus 82.5 when they have access to a computer in their homeroom versus if they don't? And of course I gave you some sum of squares information and the n size of each of the two groups. And here on the right I have the formulas that we'll need in order to compute the t in this scenario. So the first step is you have to compute your f max, which of course is the variance of the larger divided by the variance of the smaller. And we don't know which is the larger or the smaller until after we've computed the variance. So we need to do that first and then just put whichever one's larger on top and whichever one's smaller on the bottom. So the variance is computed as the sum of squares over the degrees of freedom. Now we already have the sum of squares listed here, but we don't have the degrees of freedom. Remember, the degrees of freedom is n minus 1. So here I'm going to make this equal to 16 minus 1, and your degrees of freedom for both of these is going to be 15. Now that you have your degrees of freedom and your sum of squares, you can figure out the variance is the sum of squares divided by the degrees of freedom. And if I just do the same thing, if I just click the corner here and drag it over, then I do the same thing for the second column, then I've got a variance of 67 and a variance of 77. Now I just take whichever one's larger, that's 77, and put it over whichever one's smaller, that's 67. And so here I'll just come over to the side and I'll say my f max is equal to 77 divided by 67. And then you've got an f max of 1.15, just like I showed you in the answers to your module before. This is, of course, smaller than your critical f max, which was, if you remember, 2.86. So you're free to go ahead with the rest of your t-test. So in order to compute your t here, you have to take the mean difference between the two groups minus the mean difference in the population that you hypothesize, which is always going to be 0, and you divide it by the standard error of the mean difference, which is computed as the pooled standard deviation plus the pooled standard deviation divided by the square root of n of the first group plus n of the second group, where the pooled standard deviation is the square root of sum of squares plus sum of squares of the second group divided by the degrees of freedom of the first plus the second group. So let's start here, since this will need to feed into this equation and this will need to feed into this equation. So starting here at the pooled standard deviation, we need to figure out the sum of squares of the first group plus the sum of squares of the second group. I'm just going to put up here, this is the pooled standard deviation. And I'm going to make this equal to parentheses, the sum of squares of the first group plus the sum of the squares of the second group, end parentheses, and I'm going to divide that by the degrees of freedom of the first group plus the degrees of freedom of the second group. So another parenthesis, degrees of freedom of the first group plus the degrees of freedom of the second group, end parentheses. And then, of course, I need to do all of this as a square root. So I'm going to come back to the very beginning of this formula, and I'm going to type SQRT, open paren, and I'm going to add a close parentheses at the end so that everything inside the parentheses gets the square root. Once I push enter, that is the pooled standard deviation. Now this pooled standard deviation is going to be used in the numerator of this computation for the standard error of the mean difference. I'm going to put here the standard error of the mean difference, and we're going to make this equal to the pooled standard deviation plus the pooled standard deviation. And then, of course, I'm going to put some parentheses around that to say, do the numerator first, add that together, dear computer, add together the two components of the numerator, and then divide it by the square root, open parentheses, of n1 plus n2. So n1 is 16 plus n2 is 16, end parentheses. And when I push enter, that right there is the standard error of the mean difference. We use the standard error of the mean difference here in the computation of the t statistic. So I'm going to put the t right here, and I'm going to say the t is equal to the mean 1 minus the mean 2. Minus the mean 2. And we don't have to put anything after that because this is always 0, so it's just the mean difference minus 0. And then, of course, after I put these parentheses here to say do the numerator first, then I will add a division sign, and say, now I want to divide by the standard error of the mean, which we just computed as 3, and you get your t of 1.17, which is what we computed when we were going through the lecture part of the module.